Alright, so today we're going to talk about ellipsoids. So ellipsoids are like the 3D version of an oval. So an ellipsoid has 3 dimensions. It's drawn in a 3D coordinate system. And this is an example of the graph. I know it's not really good, but it's just like a 3D oval. So just imagine like the Easter eggs. So basically, now let's look at the equation. So we have x squared over a squared plus y squared over b squared plus z squared over c squared, which is equal to 1. So that's an equation of the typical ellipsoid. And here, the difference here, if you can already spot it, is that we have 3 positive terms. So 3 positive terms are, you can say 3 positive coefficients. So all 3 terms have a plus sign in front of them. And basically you have 3 positive terms, and on the, you have 3 degree 2 terms, so you all have x squared, y squared, and z squared. They're all degree 2. And you have a 1 on the right hand side, so it's equal to 1. So now let's just try the graph. Let's try the graph in an ellipsoid. So I come up with an equation. X squared over 9 plus y squared over 25 plus z squared over 16 is equal to 1. So let's just graph this equation over here. So you should know what to do by now. So basically we graph the traces. We have the xy trace here, so we draw the Cartesian coordinate plane. This is the y-axis. This here is the x-axis. This is the x-axis. And then basically for the xy trace, so for the xy trace, if you forgot or you've never learned this before, I'll just explain this to you. So basically for any trace, it's like, for the xy trace, it's like what your graph looks like when it intersects the xy plane. So, when it intersects the xy plane. So where's the xy plane? So this plane here is the xy plane. So it's basically our typical Cartesian coordinate plane without the xy coordinates. So when our graph passes through this plane, here, we get an ellipse, right? So that's our xy trace. Then the same thing goes on for the other 2 traces. So for example, for the xz plane, or for the yz plane, this whole thing here is just the yz plane. It's like the front view of the graph. So for the front view of the graph, this is what we get, right? An ellipse in this shape. And that's our yz trace. So the xz trace is just the same thing. This over here, this diagonal thing here, is the xz plane. So all 3 traces for an ellipsoid is an ellipse. Well, I mean, from the name, you can probably tell that it's like a 3D ellipse. So yeah. So for the xy trace, we draw it by setting z equals to 0. So when z equals to 0, we have no z coordinate. Basically, our xy graph has no height, so you don't have to care about the z coordinate. When z equals 0, we get this equation: x squared over 9 plus y squared over 25 plus z squared over, so equals to 1. So I'm just gonna write that here. So we have x squared over 9 plus y squared over 25 is equal to 1. And that's an ellipse, right? So that's an ellipse with its major focus here and the minor focus here. And we just connect all these points together. Then we end up with, a rough shape like this. And then we also have the xz trace. So this is the z coordinates. This is the x coordinates. And for the xz trace, we set y equals 0. So we have x squared over 9 plus z squared over 16 is equal to 1. So this is also an ellipse. So all three traces are actually an ellipse. So this is the major focus. This is the minor focus. So that's our ellipse. And then we also have the last trace here, which is the YZ trace. So the front view of our ellipsoid. So we have Z, and we also have Y. So here we set X is equal to 0. So we end up with Y squared over 25 plus Z squared over 16 equals 1. So we have Y squared over 25 plus Z squared over 16 is equal to 1, and that's still an ellipse. So we have our major focus and our minor focus. If we connect these points together, we approximately have this ellipse shape. So now we can combine the three ellipses we have, and we can draw this graph on the 3D coordinate system. So I'll just draw the 3D coordinate plane first. That's Z, that's Y, that's X. So let me just move this coordinate plane. So I'll move it this way a bit more, and I'll zoom out. So we have X here, and we can also draw the negative axes. So basically, firstly, we can draw the YZ view, because as you can see, this is the YZ plane. It's just like the front view. That's the easiest to draw, and it gives us a best impression of what we're dealing with. So for Y coordinates, we have 5. So we have 5 and -5. For Z coordinates, we have 4 and -4. And then if we just connect all these points with a different color, you're gonna get something like that. So that's actually our approximate shape for the ellipse, but okay, we can also try to visualize the other two traces. So for the XY trace, it's the top view. So the top view is also an ellipse. So that just suggests that our ellipse is something like that, like to the back. It's not that large, so I can try drawing the XY view. So we have 3 and 3 for the X coordinates, so 3 and -3, and then for the Y coordinates we have 5 and -5. So the XY view is something like this. So if we just cut across the shape on the XY plane, that's what we would get. Then for the XZ view, it's this plane over here, this one. So the X coordinates are -3 and 3. The Y coordinates are 4 and 4. So our shape would look something like that. So it's kind of here, it's kind of really diagonal, so you can't see it well. But just imagine this is an ellipse, except for to make it look 3D, we've moved it sideways and it's slanted, so you can't see the whole shape of it. So this is our ellipse, and so basically the most important outline is the red line here, because that's our front view. The others are the cutoff views. The others are the side view and top view of our ellipse, and they're what we see if we actually look closer inside to the ellipse. So this is our ellipse, and I hope you like this video today. So remember to like, subscribe, and share. So bye.